Hello everybody, my name is Halo. Welcome to this tutorial on SRTF, which is shortest round trip time first, or known as SJF Preemptive, which means shortest job first. Preemptive meaning the job could be interrupted. So two major things to know about this CPU scheduling algorithm is number one, always we are prioritizing the process with the lowest burst time. So we are going to be servicing the process with the lowest burst time, and in case a process appears after, say, let's say process P1 is being serviced, a process P2 appears with a lower burst time than P1, then we are allowed to interrupt the process P1 in order to service the process P2. So these are the only things we need to keep in mind while doing this algorithm. Let's just go over a quick example so that you guys can understand what we're talking about here. So we have 5 processes with their burst time and their arrival time. Let's just see how this goes. Okay, so at t is equal to 0, we see process P4 coming in, and the burst time for P4 is 3. There are no other processes, so we can simply go for P4 from 0 to say 1. Okay, only P4 is being serviced. Now let's say at time is equal to 1, right? The number of processes now will be P4, and the remaining time for it will be 2, followed by P3 with the burst time for it being 8. Okay, so now let's choose the process with the lowest burst time, which is 2. So at the second, that is t is equal to 1, at t is equal to 1, we again choose to service P4 till 2. So in order to prevent myself from going very lengthy with this, let's just club this and write P2. Okay, so or if you want to understand better, let's just do P1 here and P4. Okay, now at second number 2, that is at t is equal to 2. One thing we can notice is obviously P4 is being serviced for 2 time intervals here. So now its remaining burst time will be 1. Now at t is equal to 2, we get a new process P. So wait, yeah, sorry, P1 here, arrival time is there, right? So P1 with a burst time of 8, okay, which means at this process P4 is still the process with the lowest burst time. So P4 is going to be serviced from 2 to 3. Now let's go back at t is equal to 3. Now we can see that P4 is no longer there because it's completely serviced, and this is obviously burst time 6, I'm sorry. And now at t is equal to 3, we can see that there is no process available at 3 is equal to 3, which means we only have these 2 processes available. The process with the lowest burst time is P1 with burst time 6. So at this particular point, we can say that we can service P6 and reduce its burst time now to 5. Now at t is equal to 4, what can we say? P5 is entering the scene. So P5 is entering with a burst time of 4. Now P5 here is the process with the lowest burst time because P1's burst time now is 5. So we can service P5 here until 5. We can see the final process arriving here at time is equal to 5, which is none other than P2. Now, sorry, let's go. Now P2 obviously has a burst time of 2, and now 5's burst time has been reduced from 1 because it got serviced here. So the remaining burst time is 3. Now the process with the lowest burst time here is P2, which means P2 will be serviced for the 6th second. So the remaining time of P2 will be 1. There are no other process coming in, which means P2 will be serviced again until 7. So P2 is gone fully. Now one thing to understand is, since there are no processes coming in from now on, whichever process has the lowest value for the burst time will get executed till they finish, because we are only going to be subtracting 1 from the burst time for every second we service it. Again, second is a very huge term for a process to cycle. We're just using seconds here so that it's easier to understand. Okay, so that being said, for every second, it's only P5, for example, being serviced now. Only P5 will be subtracted, and every time you subtract a number, it only becomes lesser. So when you compare which is the process with the lowest burst time, will always be that process which you are servicing currently, which means P5 will now be serviced until its completion, which will be until 10. Okay, that means I'm just writing P5 here. This will be 7, 8, 9 and 10. That is what I'm simply writing here. So once P5 is done, we still have 2 processes here, which is P1 and P8. Now P1 obviously being the one with the lower burst time will get serviced from 10 up to 15. Okay, then finally, once this is gone, P3 will be serviced from 15 to 23. Just to check if the answer is correct, since we don't have any idle time here, we can just add up all these burst times, which will get say 6 plus 2, which is 8, 8 plus 8, 16, 16 plus 4, 20, 20 plus 3, 23. That means this algorithm is right. Okay, so now let's try to find the average completion time, turnaround time, waiting time. In case you guys already know how to calculate this, you can skip right to the Python explanation, or you can just stick around if you don't know how to calculate these. So first of all, let's just name all our processes here. Okay, so you went from P1 to P5. Completion time is the time where the process has finished its service in the Gantt chart, which means let's say P4 gets completed where here 3. Okay, sorry, P4 here completion time is 3. Turnaround time is the completion time minus the arrival time of the process. So P4 arrives at t is equal to 0. So 3 minus 0 is again 3. Waiting time is the turnaround time minus the burst time for that particular process. Okay, so that will be 3 minus 3, which is 0. Okay, I'll just do another example. You guys fill the rest of it out. If you want, you guys can comment it down below. Because let's just move on. We don't want to extend this video. Now let's try to do for another process here. Let's say P5. Okay, so P5, as you can see, is getting completed at t is equal to 10. That is the completion time. What is the arrival time of P5? Which is 4, correct? 10 minus 4 is what? So 10 is completion time minus arrival time 4 will give you a turnaround time at 6. The burst time of it is 4, which means the waiting time is 2. What does the waiting time mean? Let's say a process is arriving at burst time 4 here. Now if we want to complete it, sorry, the arrival time is 4 and the burst time is also 4 here. If we don't have to wait, it'll end in 8. Okay, at all if you don't want to wait, but this is ending in 10, which means it has waited for some time. That time interval is calculated by 10 minus 8, which will give you 2. Okay, that is what we're essentially calculating here. So you guys can go ahead and fill this up and then comment it down below. Let's move on to the Python implementation of this. Right. So let's just open a file here. Let's just call it srtf.py. This file already exists. So let's just call it preemptive or whatever it is. So let's just do that. Okay. So this is SRTF Preemptive, or sorry, this is SRTF / SJF Preemptive. Now let's go back to what we discussed in our logic. Number one, this SRTF algorithm can interrupt your process, which means at any point of time we check the process with the lowest burst time. Okay, which means always check the lowest burst time. Okay, so let's just define a function here. Let's call it SJF Preemptive, or let's just call it SRTF, and let's take a process list as an input. So what is this process list? Before we move on to this function, this process list is nothing but this box here in a list form. So since we are always prioritizing the lowest burst time, the best way to approach the solution is going to have a process in the following format. Have the burst time first, followed by the arrival time, and then followed by the process ID. Okay, so which means this will make sense in just a bit because how we are handling this issue. Now let's create a process list from this following table. So P1 burst time will be 6, arrival time will be 2. So burst time is being first, 6 to P1. Okay, so let's just create a list with 6 2 followed by P1. Okay, let's just do this for the rest. So right now I've created a process list. This process list simply consists of this box right here in this following format. This burst time first, arrival time second, then the process. Okay, so now that we're clear with the process list, let's move on. Number one, let's repeat this algorithm until this process list is empty. That means once a process is completed, not equal to an empty list. That is, until if a process completed, we pop that process off from the list. Until this process completed, we are going to do this algorithm. Now, we need a few things in order to showcase the user about the algorithm which I have done. So let's just create a Gantt chart and a completion dictionary in order to say which process completed when. Okay. Now let's move ahead with our implementation, and obviously let's just say time is equal to 0 because that's how we move. And for every iteration, what you do is you increase time by 1. Okay. Now, two things you have to understand. Number one, there's let's say there's an edge case where in that particular second there's no process available. Okay, so that we have to handle. Number two, let's say there are processes available, because in this example at every second we have some process available. Let's focus on that first. Okay, let's take an available list and then let's iterate over this process. So for P in process list, and see, since this is the way we have described a process, which is burst time, arrival time and PID, we can say P of 1 if P of 1 is less than equal to the current time. Correct? So this is where a problem comes, because we cannot put T plus is equal to 1 here. Instead, what we can do is we can go ahead and put it below here, because we are seeing which process are not arrived or which process have arrived at T is equal to 0. That's how it will improve. If we add the time interval here itself, then that will mean we are only checking for T is equal to 1. So T is equal to 0 will be skipped. In order to prevent complete confusion, let's just take this T plus is equal to 1 out, and we'll bring this back into the equation, because if we don't include the time, we cannot know which process ended when. Okay, so let's compare with this the available time. So when a process arrival time is lesser than the current time, that means that process is available. Let's just append this to the available list. Okay, this is done. So let us focus on a case where there are no processes available, that is available is empty. Okay, there is no process there currently in the available for the user to service, which means we just increase the time by 1. Let's move on to the next time. Let's append that the CPU has been idle for this particular second, and we can just do continue. Okay, so let's move on to the next time interval. Okay, so if you put continue, you don't need to put an else statement, but for the simplicity, let's do that as well. Okay, now what if we have an available list which has a few processes? We need to find out which process is the process with the lowest burst time. That is why I am telling you guys to put the process in this particular format, because we can simply just do available dot sort. It will sort with respect to burst time, and now the available of 0 will be the shortest time that we have. Okay, now let's say our process is going to be available of 0. Okay, let's create a copy of this process, which will make sense in a bit. Okay, so we can again do pop of 0. If you guys don't want to do of 0, because if you think there will be a shallow copy, that's no, you don't have to worry about that. Okay, so number one, what we are doing is we are going to be servicing this process in this time moment. That means we can change the burst time of this process by 1, because in this second we are only processing that particular process. As you can see, from let's say from 0 to 1 we are doing P4, which means for P4 the burst time is decreasing by 1 with every second it's being going, which means the burst time can now be minus equal to 1 for P4 or any process for that matter. So we are updating the burst time of the process. Now let's say if the burst time is 0, that means the process is no longer in the queue. Okay, that is one case. Or if the burst time is more than 0, that means the process needs to be serviced again. Okay, so it has to be put back into the queue again. Number one, when you're servicing a process and we're updating the process, it's a good measure to remove that process completely from the process list. Okay, so process list dot remove, we can go with copy process. Okay, we have to remove this process. You can put this over here or put this over here, which will be more apt. We're just going to remove this process from the process list. We are changing the new process, that is we are creating two copies. In one copy we are updating the burst time, and in the copy we are removing the process from the process list. This is done for one simple reason, because once we update the burst time, we cannot remove process from this list, because now there will be a different burst time, so this won't be available for that list. For that reason alone we are removing from this. Okay. Now if process of burst time is now equal to 0, which means there's no more time for the process to be serviced, what we can do, we can simply increment the time by 1 and then continue, right? Else there is more time for the process to go. What we can do is, for the same process list, we can just append our process, which is the updated process with a lower burst time for that particular process. So what we are doing essentially is, let's say we have a list with, for simplicity, let's say we just have P1 with a burst time say 6 and arrival time say 2, and then we have P2, which is again with a burst time of 3, sorry, let's say burst time of 3 and arrival time of 2. Okay, great. So now P2 will be the process with the lowest burst time. We do this by sorting, which will be P2 will come first because this is lower than this. We take this out, we subtract this by 1, increase the time interval, and we do this by simply, if this is the list, we are taking this, removing from the list, performing this particular update, and then putting this back into the list for that, so that the next time we search, again in this case again P2 will come because it is the lowest. This will be done until this becomes 0, in which case we just remove it and we don't re-add this back. That is what we are trying to do here. So until that, I hope this is you guys can understand. So instead of putting this t here, because in either case t is going to be incremented by 1, and in that particular second we are going to be processing this particular value. So that can be process of PIT, which is process of 2. So this is being serviced at that particular time. In case we are going to be, there is no further thing, there is nothing to be done yet, the process is completed, we can just continue, else we can add this back. Now we have continued, we have a Gantt chart here. If we just run this, I think we can understand a bit. If name, let's say equal to, let's just do main, and then just go back here, let's just add a process list. From there, let's just call SRTF of this particular process list. Okay, and now obviously once all of this is done, let's just print Gantt. Okay, to see what we have achieved so far. Okay, so one thing you can see is there's an infinite loop, which means we did a mistake somewhere and this thing is keeping on repeating, right? I think I figured out what the error is. Here we are updating the burst time of the process. We are doing P process of 1, when in reality it has to be process of 0, because burst time is always in the 0th second. Okay, that is what is kind of I think what is stopping us from moving forward. So if we are just decreasing the burst time by 1, removing this process, and if the process has no more burst time, we are removing the process completely, or we are appending this back to the process. Now let's just run this and see how this works. And let me just go and just clear this terminal so that you guys can see it a bit better. Yeah, so as we can see, this is our Gantt chart. Okay, so we have P4, P4, P4. Again, when you can actually check this with here, P4, 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 then followed by P1, P5, P2, P2, P5, P5, P1, P5, P2, P2, P5. Okay, the entire thing is right. If you want, you can pause and check it. Okay, so this is what the SRTF algorithm is. Now, let's try to include the completion time, the turnaround time, and the waiting time, because this is something that you will be expected to do, right? So, in order to do this, there are few things that we have to keep in mind. First, we need to keep track of the burst times of every process. This is done because we are changing the burst time in every arrival. So when we are completing it, we don't know what the actual burst time of the process is, because we are always dealing with a copy of the process only, okay, or the process which is updated. We don't know what the original process is. So let's just go through all the processes, okay, and let's just add burst times, okay, of what is the PID? The PID is process of 0, 1, 2, okay, 2 is equal to nothing but this, which is I of 0, okay, this obviously is I of 2, burst times of I of 2 is that P of ID, and this will give you this answer. Okay, so now this is where we have to note down our completion times, because why? Because there is no longer the process needs to be serviced, okay, which means number 1, we can change the completion. Okay, let's just add a process name is nothing but process of 2, arrival time will be process of 1, and the burst time, again I'm saying because we keep updating it, so we just refer from this dictionary to see what the original burst time was, okay, because that is what we use for this calculation. Okay, now with this being in mind, let us do some more calculation. Number one, let us say what is the waiting time. So again, the formula is there. So for completion time, turnaround time, and waiting time. Completion time will be nothing but the current time, correct? And what is the waiting time? You have to keep that in mind. What is the turnaround time? First of all, that will be CT minus the arrival time, as we have written right here. So that will be the turnaround time will be completion time minus process of 1, which is the arrival time. What is the waiting time? Which is nothing but the arrival, the turnaround time minus the burst time, which means turnaround time minus burst time. Now, one thing to keep in mind when we note the time here, that doesn't mean that we are servicing for that particular second. It means that it is being completed in that particular instance. Okay, so that is why we are increasing this time by 1 and we are subtracting this by 1, which means it is processing. Once this is 0, we are saying that for the next second it will get completed. Okay, so at this particular second, this you have to understand it as, that's why we when we mentioned it before, we say it as 0th second or 1 second. Okay, 0th or 1 second. This process P4 here is being completed at the second. Okay, so this will be second, which will mean that when t is equal to 2, we do t plus is equal to 1, which will bring it to 3, which is after the second will complete, and that is when we make these seedings. As you can see, when t is equal to 2, let's say we are doing this plus equal to 1, now the t is 3, and then that is why we are doing all these calculations here, and that is why you see that P4 is 3. So that if you have that question in mind, so why we are doing that, that's simply to note down stuff like this, okay, and so that this while loop stays consistent and we can note those these times. Now, let's just put a completed or completion, which is our dictionary, and let's just put process name followed by let's say CT, TT and WT. Okay, so this is something that we're keeping in note every time on process completes. Okay, so this by itself is SRTF as a whole. Let's just run this process again and then print our completion times as well, completion dictionary as well. So if we run this again, we can see P4 is getting completed at time interval 3, its turnaround time is 3 and its waiting time is 3, which means that we are making some mistake here. Let's just see what that is. Process of 0 here will be nothing but 0. So we are doing nothing here. That is why we are going to be inferring from the burst times dictionary. Okay, that is why this is a very important thing, because we are only checking when process of 0 is 0. So when this is 0, burst time is obviously 0. So anything minus the burst time will be that anything value only. So instead of doing this, let's just go for burst times of process name. Okay, let's just run this again and see what happens. As you can see, this has changed. So let's check this with our calculated values here. Let's just check for these two, which means obviously the rest will be true. So P4 will be 330. Let's see P4 330. That's right. P5 will be 1062. Let's go for P5. P5 will be 1062. So this is right. This is how the algorithm basically works. This will be our Gantt chart, that of 0 to 3. This P4 is being executed. From there, P1, P5, P2 that we've already checked. And these are the process with their completion time, their turnaround time and their waiting time. If you want to make it a bit beautiful, you can just traverse through this dictionary, print it a bit better to show it to the user. This is the SRTF algorithm. I'm going to be uploading a detailed code for this, including everything, all the stuff you need to know about this in the description in the GitHub repository. So you can check that out, you can refer it. My advice is try this algorithm on its own. Even though this video seems very large, the algorithm by itself is very, very intuitive only. It's very logical based. If you understood the concept, if you watch this video once, try this in Python, and definitely this is something that you won't forget. Thank you so much for watching this video. If you want to watch more of these videos, I probably have more. You can go check this out in the comments. If you like this video, please give this a like, and thank you for watching.